is for when you have triangles that are not right. Okay? These are going to be for non-right triangles. And we use this when you know, excuse me, an angle and its side opposite. What'll happen a lot of times with these things when we draw our pictures and diagrams, when we start figuring out what parts we know. I know how we would always circle theta, we would draw to an opposite and do all that kind of fun stuff. And we label hypotenuse and adjacents. Well, in here, they're not right triangles anymore. So there's no hypotenuse, there's no adjacents like that. You still have an angle and a side opposite you. So you still have an opposite than one side that you are looking at. Okay? So what happens is we label our triangles just ever so slightly different. We use the capital letters still for our vertices, and we use lowercase letters for the sides opposite. So, for example, angle A looks at little side A. Angle B looks at little side B. Angle C looks at little side C, and so on and so on. Okay? So as we get going into these things, we're going to use this thing called law of sines. Law of sines is nothing more than a giant proportion. If you guys remember, proportions were just fractions that were set equal to each other, just all a whole bunch of ratios. Okay? So what happens is this. There's a formula called, it looks like this. The sine of an angle, sine of angle A, is to its side opposite equals the sine of angle B as to its side opposite.
Oh, yes. This is going to be fun.
What trig function are you using? What's that?
Yep.
What's that one? There's like, isn't there like a difference like that where it's the guy from The Hangover where he's looking at all the math? I see him right now going,
When he's in the casino?
yeah, exactly. Totally, yeah, you can totally picture it.
Why is he trying to solve it?
Why are you trying to solve it?
You're not supposed to solve it. Tell me what trig function you use. Oh, there's no other trig. You know you had a test on this yesterday. You should be ready for it. It doesn't look like you're ready for it.
Say all three.
Oh my goodness. Close that for me.
I feel bad.
The what? No. You had a one. You got the first one wrong. You had a 50-50 chance to get the second one. Anyway, hey, my advice to you: study. What happens here, guys, is you get this pretty quick setup. Okay. Law of sines basically says the sine of an angle is to its side opposite, the sine of the other angle to its side opposite, and so on. Obviously, in this case here, we're not going to be using all three of those fractions equaling each other. You're going to need to write this down so you can do this. So put away your videos and write something, okay? When we use these things, you'll be given one set, or you'll have to find one set to make them work, okay? This stuff is relatively straightforward. It's nothing more than what winds up being basically a two-step equation to solve these things. Okay? For example, if we use, let's see if we get to this one. If I look at one like this, I have a triangle ABC. I gave you two angles and a side. I must have erased the other. So we have little a, little c, and little b. Okay. I usually write those lowercase letters on the interior just so you know which ones are which. Just like before, when we had right triangles, you guys were always given three parts, whether it was two angles and a side or two sides and an angle. You would have to find three other pieces. Well, here again, we got to find three pieces. If you look at the diagram, we need to find angle C, little a, and little c. So what I like to do is I always make a list I know I have to find angle C. I gotta find little c and little a. Sometimes it could be written as AB or side BC. Just remember that that's just what they're standing for, side opposites, okay? So what angle and what side opposite are you given? Well, which angle has a side opposite? Angle B. So here's what we do. Whenever you know that you've got an angle and a side opposite, I want you guys to kind of circle. Because you're going to use that set, that angle and that side, to solve for both solve for little a, and then we'll reuse it again in a minute to solve for little c. Okay? But not 48 over 28. Sine of 48. Okay? So what happens is we have the sine of 48 is to its side opposite. Sine 48 is to its side opposite, because that's b to little b. Okay? I'm going to find little a first, because I know what angle a is. So I have sine of a is to little a. And notice this becomes just a fraction equal fraction problem. When you have fraction equal fraction, that basically means why don't you just cross multiply? And if you recall, we've done stuff like this with exchange-o, change-os, and all that as well when we did our trig stuff. Remember, the unknown was in the denominator, we switched it. Remember that? Guess what happens here? Unknown's in the denominator, the sign's here. What do you think is going to happen here? You're going to switch. How do you undo then dividing by 28? Multiply. So what happens is that your value of a, that little a, winds up being 28, because I had to multiply it up to the sine of 35 over the sine of 48. We did exchange-o, change-o, and multiply by the denominator. Okay. Now you have, just like we did before, we have some crappy decimal. That's all that is. The sine of 48 is a crappy decimal. The sine of 35 is a crappy decimal. 28 is the only clean-ish number. What we would do is just use the calculator in the fraction bar and type it in. So in the calculator, sorry, yeah, find it. Yeah, if you round it correctly, it should be 21.6 something. Yeah, that sounds right. Let me turn this back on here. When you switch resolutions, sometimes some of the ancillary things disappear. So in the calculator, I would have just typed in, where it was. See my fraction bar, 28 sine 35 over sine of 48. And if you did that right, you get 2161. Okay. So that means that little a is 2161. Now, that's just the first part of the triangle. Let's make my list here. Since we know two angles in a triangle, how do you find the third? 10. How many degrees are in a triangle? 180. Does that ever change? Nope. So take your 180 and subtract out 48 and 35. What do you get? 7. Good. Now you know what angle C is. Angle C is 97. Now I can use that 97 to find the little c. But what I'm going to do is reuse what I knew to start with. I know the sine of 48 is to 28, because that was our given, side of the angle, angle to side opposite. That then has to equal the sine of 97 over little c. And you'll notice, isn't that little c in the same position as we found little a?
Yes, sir.
That'll happen quite often if you start up with these things. Okay? we do an exchange of changeover, multiply by the denominator. Little c will equal 28 sine 97 over sine of 48. Sine 97 sine 48. 37.4 when you go to two decimal places on that one? You okay with that? And here's the kind of the downfall of log sines, and then again when we get into what's called log sines tomorrow, there's really no great way to check your work. Whereas when you had right triangles and you were finding side lengths, you could always double check it with Pythagorean theorem. There's no Pythagorean theorem for these things because these aren't right triangles. Really the only thing that you could kind of do to see if it makes any sense, does the biggest angle have the longest side length across you? Does the smallest angle have the smallest side length across you? If those pieces are true, you're probably on the right path. And again, you'll notice there's so many buttons you're pressing here. This is one of the ones that it's so important to write down what you're doing before you do it. So that way, I think we had someone in the second hour where we solved one of these things out, and instead of doing 28 sine 35 over sine 48, I think they hit 46, which meant that value was wrong, which means if you reuse it again later, the next value is going to be wrong, no matter what you do. So it's so easy to write something down incorrectly. Just be careful, okay? So it's not terrible, is it? Yeah, it's really not that crazy. Obviously, sometimes what will happen is you might have to do what first here? Make the triangle, exactly. Does the triangle have to be perfect and beautiful? Yes. No. What does the triangle have to have? You just got to make sure that it has 3 sides. Okay. So let's try that again. What I want to do is just draw a picture, label it A, B, and C. Does not have to be perfect. Fill in the blanks of what you know. Angle B, 17. Angle C, 46. Little c, 18. Make a list of what you need to find. Well, you got to find A, and little b. What angle and what side do you know across from it? Start with C. Circle it. That way you know which ones to use. So I circle this. That way I know to use that as my set. Which side, or which piece, excuse me, is this forcing you to find first? Well, okay. Could you find angle A real quick? Yeah, you can find angle A real quick. Yeah, you just subtract it out and you get that. But when I'm looking at it before I get that far, the only side that I can do before I get to angle A would be little a. Everybody okay with that? Now, what you would say is if you add those two together, subtract from 180, you'd have, what was it, 117? You have 117 for angle A. That's the easy stuff. When you have two angles, you don't have to do as much work. When you don't know the angle, I'll show you guys how to do an inverse. But again, it's just a button, the X up after that. So you have all use inverse function. Okay. So if I have to find, excuse me, I have to find side B, but then I got to find side A. And I'm going to use C to find both. So I have the sine of 46 is to 18. Sine of 17 is 2b. That's for one setup. Since I'm already there, if I redo that as well, sine of 46, still the 18. Sine of 117 is 2 little a. Notice how our unknowns are in the same spots as they were last time around as well. Exchange O, multiply by the denominator for both of them. Okay? For both of them. Bless you. So little b, the 18 up, Change down. Little a. Move the 18 up. Change down. When you have to find the two side lengths, usually the algebra setup of it, they're going to be the same setups, just different buttons. Okay? And now it's just a matter of pressing the buttons correctly and not to screw it up. Okay? So if you type that in, let's see, we got 18 sine 17. 18 sine 17. It was over sine 46. 7.32. You okay with that? Do the same thing for the other one, 18 sine 117. And this one would round out to 22.3. If I did this right. Okay. So 732 and 22.3. So if I look at my picture, the biggest angle is at the longest side length of the triangle. Okay. It's the smallest angle have the shortest length. And then process of elimination, all that's left is the median. Right. Not tough, is it? I hope. Or, I mean, I don't mean it as in I hope it's tough. No. Let's look at the other version of this. We have to find a neighbor. This is the version of law of sines that you guys will spend a lot of time on when you get to Algebra 2. It's called the side-to-side angle case. There's a lot of weirdness that can happen in this scenario depending upon what values you get. It's called ambiguous. This is a bunch of stuff you guys don't need to worry about, but later on, this is kind of the weird one. But for us, we're going to set up the same way. So as you're going through this, look at the diagram. Decide, do you have an angle and side opposite to start with? Yeah. Which angle, what side? We have the A's, okay? So I have big A, I have little a here. Big B, little b, big C, little c. So I'm going to circle that. What other part do we know? Which is what? It's a side or an angle? Side for what? So what angle is this forcing us to find? B. It's forcing us to find angle B. Okay. So what we do is we set it up the same way. Sine 33 is to 27. Sine of B is to 40. Now, we've all found angles. We had to do that on our tests and all those quizzes and stuff we did. We had to use the inverse function. Remember that? Second sine, second cosine, second tangent, how you got the sine -1, that kind of stuff. Well, in order for us to be able to do that, we have to figure out what this side is equal to. But first, we have to move something. How do I move the 40? Multiply. So what happens is when we're trying to find an angle, all we do is just move the 40 over. 40 times the sine of 33 is you got to multiply over 27 is the sine of B. This is just some crummy decimal. What we do is we enter that whole thing in the calculator, get some crummy decimal, and it has to equal the sine of B. So if I do that, do my fraction bar, 40 sine 33 over 27, and I hit enter. That value equals the sine of B. Those are heavy. Remember when we did this last time? Last week, actually? Yesterday? Second sine of your answer. There's your angle. You're still doing the same process when we had to use the inverse functions to get the angle. It's the same thing. It's just with law of sines as opposed to SOHCAHTOA stuff. Which gives us an angle then at 5379. Okay. How many degrees are in a triangle? We know two of them. What would you do to find the third? Yep. 93.21? Sounds good. So I have then 93.21. And I got to find little c, which falls back to the exact same scenario we just did 2 examples. You rewrite your sine of 33 for your a is to the side opposite, is to the side opposite, which is 27. Okay. Change with the c and the angle, the sine of 33, and then multiply the other side by 27. So you have little c, 27, sine 93.21 over, right, sine. And this one I run up to decimal places, I get 49.5. Which one? What do you mean? Yeah, anytime you find an angle, you have to inverse. If you don't know an angle, you have to do an inverse function to find the angle. That's how you got to do to get the angle part. What'll happen here, which I know it'll happen to somebody in this room, when you're doing this part here, you're going to hit a wrong button. And you're going to hit inverse sine, and it's going to come up and say domain error on you. If you recall when that happened with the SOHCAHTOA stuff, that meant you could have had the wrong tree function, or your fractions were flipped. Same thing can happen here if you get the domain problem. That just meant that you did something incorrect inside of here. All right, if you get a domain error, it means you set it up wrong somehow. Otherwise, if you press a wrong button, it's still going to give you an answer. That's kind of the weird thing with this, with law of sines. You kind of have to cross your fingers and take a leap of faith that you set it up right. It's not the easiest stuff to double check to make sure you did it right. Not terrible. Let's try going with one more angle real quick. Yeah, that's a B up there. Why don't you guys take a minute and solve this triangle? When I mean solve triangle, means solve all from the parts. Yeah. So, second sine of your same. It still works the same way. So you use this shift function with the sine inverse, and then you hit the second answer. That was your last answer. So it should still work the same way.
Be correct.
All right. Well, okay, good. I was just trying to do it without you writing it down. Need to write that out? Okay. Remember, in this case here, you have to inverse the sign to get to B, and then you just subtract from 180 to get to A, and then cross multiply through. Now, what I have for us this afternoon is one of the things that I realized as I was printing these things through, you know how I got in the habit of writing down what you guys need to find on the right triangle stuff, finding all the side lengths of that. Well, I did the same thing here, but I didn't use little a and little b. I just used the actual segment themselves. So I just want to walk through real quick and make sure you guys put little a, little b, little c in the right spot. Did I grab it up? Uh-oh. I did grab it up, and you can have one for her. So real fast, if you look at this this sheet, which means I can get more anyways, I can get my point this bond. I just want to make sure you guys fill in the blanks in the right spot so we don't mess anything up. Let's see here. Question number 1. Your triangle's labeled out like this. So this is little b, little a, little c. Fill that in there. I believe I wrote down find BC. BC is technically what segment length? Little a, okay? Do you see what I mean by right? Because when we did the right triangles, I always wrote out the 2 letters from the segments. I was in such the zone of doing that for so long, I forgot. Oh wait, no, and we just use lowercase letters. So. Yeah. On 2, it's B, C, A, so it's little b, little c, little a. This one, BC is little a, and AC is little b. I don't know if you noticed, but if you have the 2 letters, it's the little letter of the one that's not there. So if you've got segment BC, what letter is there of the triangle? A.
Oh, what?
3. I'm just trying to draw it out real quick. I know, I'm getting there. So again, as you go through these things, let's see, AB is little c, BC is little a. This bond, all I was doing is that on this sheet, you'll see I put everything as 2 letters for the segments. I was still in the mindset of doing the right triangles since we did that before. And we're showing you guys how to do this with just a single little letter. So I just wanted to go back and relabel it for you because on this sheet they're not labeled that way. So, for example, on number 1, segment BC, if you look at it, it's little a because it's across from big A. Does that make sense? So it goes 1, 2, 3, 4 as you're going around, just like it does in the worksheet. So you can just relabel with a little lowercase like this. All right. I think you guys will be able to knock out those 4 without too much of a hassle. Yes, ma'am. No. What do you want? Hi. Well, exercise. Oh, no, I'm not here to invest there. You show the formula So if this is period to your right, you use the inverse of pi equal b. So you have set up so you zero fraction mark. 19 sine was it 26? Wait, 76. That's that is over 26, and I hit enter. So right now you've got tracking down. Okay. To get this the inverse, you have second sine. Second sine, second answer. That's what it is. Okay. So you have 45 seconds. All of it. All of it. Well, we're not going half the time. Anyway. Oh, that's not big.
did. Yeah, start getting in here. Huh? Yeah. So what's that your opposite? Yes. Oh yeah. Those are the points. That. What other side do you do? What is that? Whoa. What angle is that? Okay, so you get line A, B, over little b, which was. It's like it's like this one here. By 19. Someone got something? Get this one here. This gives you some practice. Use it for neutral code. I run the first one. You just figure out this practice. Second side up, second answer. Just like you did on the trick try to find out.
Yeah, guys, a lot of times for that third angle, I know you have to subtract from 180 to get to it anyway. You don't have to show me write it down. It's not a big deal.
So, this gives you 3 decimals.
Good boy. I'll get up this.
46. Right. Use the sign. I don't know why you're doing the square root.
So you got this.
Okay? I didn't hear you. What? That means you probably have a domain here, which means you set it up.
Yeah. What's wrong?
Oh, there's no.
Just don't do it all at once. Just type. Put this out there.
What do you know?
26. Hit enter. This equals the sign of an egg. That's good. Sign.
Oh,
That's why you're doing it. How did you get the, how did you guys get the before? The same way, doing the same thing. Good. You had to find an angle, you had to change the first tangent or something, you had to find the decimal, the second tangent of an answer. You did all that before, it's the same button. Just different process by which this works. Yes, that's fine. That's how you start. Well, that's what we're going to use. That's what we use.
You use law science multiple times. You can't use Pythagorean theorem, but that's what we were doing. You'll be able to. So you just use it with that given study. It's the same thing. It doesn't matter. Don't worry about it. It is a little bit. Yeah. There's no way to use the sign of it. It's the sign of it. It's 18.9999. That's going. Every once in a while, they come across the town and things like that. Something. Oh, really? Like many of those numbers that I've seen, so that you're on the right track. I think that for here. This is the same way. That's you got it 97. Oh, I see. We got the frame here. 97. Change to a change to a pair. Does that make sense?